Hello, welcome back. Before starting a part 2 of coordination chemistry for 12th standard, let me solve one question. I have taken 1 mole of PtCl4 dot 2HCl treated with silver nitrate produces 0 mole of AgCl. Here the question is, what is the secondary valence of Pt? Since there is no AgCl precipitated out, so definitely no Cl is present outside the coordination sphere as counterions. Let me write this compound according to modern terminology. You see, this is the square bracket. Inside this square bracket, you will find Pt, and there are 4 chlorine atoms over here and 2 chlorine atoms over here. So total 6 chlorine atoms. Here there are 2 H atoms, and these 2 H atoms written as H plus, so it cannot be written over here, it should be written over here. So H2, and the structure will be H2 PtCl6. This complex on treatment with silver nitrate won't give any AgCl, no AgCl. Why? Because all the chlorine atoms present inside the coordination sphere. As all the chlorine atoms in form of Cl minus are present inside the coordination sphere, they cannot precipitate silver nitrate into AgCl. It cannot precipitate silver nitrate into AgCl. So here the secondary valency of Pt is definitely 6 because it is connected to 6 chloride ions. So it has here the oxidation because in H2PtCl6 Pt is bonded to 6 Cl minus ions. So its coordination number is 6, or you can say secondary valency of Pt in the above complex is 6. Next, ethylene diamine tetraestate. A trick will be given how to remember the structure of ethylene diamine tetraacetate. Ethylene diamine tetraacetate. You see, this is one word. First thing. Second, you see there is only one M, and this is EDTA, and the charge on it is 4 minus. We have to write the structure of ethylene diamine tetraacetate. This is a hexa dentate ligand. Now we will draw the structure of ethylene diamine tetraacetate. You see, ethylene means it is CH2 double bond CH2. When it is bonded to two amine groups, the double bond over here becomes a single bond. The double bond over here becomes a single bond. And you will find two NH2 groups on two sides. Now I have written ethylene diamine. You see, I have written ethylene diamine, but it is connected to 4 acetate ions. The structure of acetate ion is CH3CO minus, but here it is written as HCH2CO minus, and this H will be removed, so you will find 4 CH2COO minus groups on 2 nitrogen atoms. So we have to remove these 4 hydrogen atoms. So the structure will be CH2 single bond CH2 N and these 4 hydrogen atoms are substituted by CH2CO minus. This is ethylene. This is diamine tetra acetate. This is popularly known as EDTA 4 minus. Why 4 minus? 4 negative signs are there on 4 oxygen atoms. But it is hexadentate. Why it is hexadentate? As it has 2 lone pairs on 2 nitrogen atoms and 4 minus charge on 4 oxygen atoms. So total number is 6. 1, 2, 3, 4, 5, 6. These 6 sides can be connected to central atom through coordinate bonds. So EDTA is a hexadentate, or the denticity of this EDTA is 6 due to 2 lone pairs on 2 nitrogen atoms plus 4 negative charges on 4 oxygen atoms. Now let us start part 2 of coordination chemistry. In this part we will discuss about the nomenclature of coordination compound, how to write the nomenclature of coordination compounds. Nomen means, nomen means name, clutcher means to call. So how to call the name of a compound we'll learn over here. Nomenclature is an important part in coordination chemistry because of the need to have an unambiguous method of describing formulae and writing systematic names, particularly when dealing with different isomers. The formulae and names adapted for coordination entities are based on the recommendation of the International Union of Pure and Applied Chemistry, IUPAC system has recommended the nomenclature of different coordination compounds in a systematic way. So how to write the formulae of mononuclear coordination entities? Formulae of mononuclear coordination entities. The formula of a compound is a shorthand tool used to provide basic information about the constitution of the compound in a concise and convenient way. Mononuclear coordination entities contain a single central metal atom or ion. The following rules will be applied while writing the formulae of the central atom or ion is written first. Next, the ligands are written in alphabetical order. Here charge on the ligands, your charge on the ligand is not taken into account. Polydentate ligands are polydentate ligands are also written alphabetically. In case of abbreviated ligand, abbreviated ligand, the first letter of the abbreviation, the first letter is taken into consideration. In case of abbreviated ligand, the first letter is taken into consideration and written in the formulae. The formula of the entire coordination entity entire coordinated coordination entity is enclosed in square brackets. When ligands are polyatomic, their formulae are enclosed in parenthesis. ligand abbreviations are also enclosed in parenthesis. Parenthesis means moon bracket. There should be no gap or space between ligands and the metal within the coordination sphere. The charge of coordination entity, the charge of the coordination entity without the counter ions, or ion, the charge of coordination entity without the counter ion or ions on the right hand top of square bracket, right hand top of square bracket. Or you can say right superscript, or you can say right superscript, right superscript. The number of the charge, is written before sign. Example, CuNH3 whole 4 2 is written before plus. You see 2 is written before plus. This is the square bracket, or you can say coordination sphere, and this is the metal atom, this is the ligand, and this is the coordination number. But if it is monodentate, the coordination is easy to find. Otherwise, we have to find the number in a particular process. The charge on the cation or cations is balanced by the charge on the anions. The charge on the cations is balanced by the charge on the anions. Charge on the cation should be balanced by the charge on anions. Charge on the cation is balanced by the charge on the anion, so that the total compound can be written in a neutral form. You see, K4 Fe CN6 4 minus K plus 4 K plus ions are there, and efficiency is 4 minus is there. If I write these two parts in one formula, I have to write K4, then square bracket starts Fe CN6. You see, here it is 4 plus and here it is 4 minus. The charge on the cations 4 plus is balanced by the charge on the anions, so that the total compound can be written in a neutral form. K4 Fe6, K4 Fe6. Let us do some examples so that it will be easy for us to understand the points written above. First one, example 1, tetramine aqua chlorido cobalt 3 chloride. Tetramine, you see I have written double M over here, tetramine aqua AQUA, then chloride is written as chlorido, here E is replaced by O, chlorido, then cobalt upper Roman numeral chloride, tetramine aqua chlorido cobalt 3 chloride. Let me show the different parts. This is tetra, then amine, then aqua, then chlorido, then cobalt 3 chloride. You see, this is the name of a complex compound, and we have to write the structure of this complex compound, or you can say formula of the complex compound. You see how to write. Rule number 1. You see, rule number 1, the central atom or ion is written first or listed first. So here central atom is what? Here central atom is cobalt. Here central atom is cobalt. Then ligands. One is amine, another one is chlorido, then aqua, means amine means NH3, aqua means water, chlorido means Cl minus. And number of amine groups are 4 over here, and these are written alphabetically. A, then AM, A, M, then AQ. So between AM and AQ, AM will be coming first alphabetically. Then after A you will find C. So it is written alphabetically, and in the formulae we to write the ligands alphabetically. So amine means NH3. You see, NH3. How many amines are there? 4. So just write 4 over here. Subscript. Then aqua. Aqua means what? Water. I told you, if the ligands are polyatomic, should be written in parenthesis. Parenthesis means moon bracket. Then chlorido. Chlorido means Cl minus. It's not polyatomic, so we can write Cl. No need of writing the charge. You see CONH3 4 water Cl. Then square bracket ends Why 4 ammonia molecules are there? It is written tetra. Why 1 water molecule is there? Because it is written only aqua. Why chlorido? 1 chlorido? Because there is no numerical prefix. So it is Cl only. Then outside the square bracket you will find chlorine also, chloride. But how many chlorine atoms, that we have to discuss after balancing the charge on the cation and the anion. You see, we have written cobalt first, then the ligands alphabetically, then chlorine, then square bracket ends, and then ClX. You see, it is a trick to find out the value of X, and here the upper Roman numeral for cobalt is 3, means its oxidation number is plus 3. It is 3, means its oxidation number is plus 3. So we have to find the charge over here on the square bracket. How? You see, the oxidation number of cobalt is plus 3. For ammonia it is 0, so 0 into 4. For water it is 0 into 1. For chlorine it is minus 1, so minus 1 is equal to plus 3 plus 0 plus 0 minus 1, that is plus 2. So the charge on the coordination entity is plus 2. Let me write again. CO NH3 water Cl, and I should write the number before the charge 2 plus, then Cl X. I have to find the number X over here. How? You see, here it is written the charge on the cation is balanced by the charge on the anions, so that the total compound can be written in a neutral form. You see, this is 2 plus, so definitely on the anion the charge should be 2 minus. So the charge on the anions should be minus 2, but it should be written as 2 minus. You see, Achha. You see, the charge on Cl minus is minus 1. The total charge on anions as counter ions, because this Cl is present outside the square bracket, so it is a counter ion, will be minus 2. So when I will divide minus 2 with minus 1, I will be getting 2. So definitely X is 2 over here. So I can write CO NH3 water Cl square bracket ends, then Cl2. You see, this is the formula of a coordination compound given over here. Let us do another example. Example 2. Potassium tetrahydroxido zincate 2. You see, this is potassium tetrahydroxido zincate 2. Potassium tetrahydroxido zincate 2. You see, this is the counter ion, and the potassium being a positive charge should be written before the anion. You see, before the anion K, but I do not know the number of K plus ions present over here. So we have to write X, K, X. Then in the complex part, I have to list the central metal. Here zincate is written. You see, as it is written zincate, it is there. This is an anionic complex. Another way to find the charge on the complex or cationic or anionic, you see it is written. So definitely this is a negatively charged complex. This is a negatively charged complex. Here I have to write the number. So here it is zinc. So zinc is listed first. Zinc is listed first. Then the ligands. You see tetrahydroxido, only one type of ligands. Means this is a homoleptic complex. Homoleptic complex means one type of ligands. Hydroxido means OH minus. OH minus. This is hydroxide. This E is converted to O in the name of the complex compound, hydroxido. How many hydroxide ligands are there? 4. So I should write in bracket, then 4 as subscript. You see it is Kx in square bracket, Zn OH 4, and I have to write the number before the negative sign. As it is an anionic complex, the charge on the complex must be equal to the charge on the cations. You know, it is written we have to balance the charge. The charge on the cations is balanced by the charge on the anions. And you see, so, and here the upper Roman numeral for zinc is 2, means its oxidation number is plus 2, or the charge on zinc is plus 2. So let us find the charge over here. Zinc means Roman letter 2, upper Roman numeral 2 means plus 2. OH minus means minus 1 into 4 is equal to how much? 2 minus 4 is equal to minus 2. And minus 2 is written as 2 minus, or you can say the number is written before the negative sign. Here it is negative sign is, here is the negative sign is written, and in the question mark I have to write 2 only. I have to write 2 only. Okay. So this is Kx square bracket starts zinc OH whole 4 ligands, and this is 2 minus. Definitely the charge on the cations is 2 plus. Why? 2 minus must be balanced by 2 plus. So here we can find the value of X over here. How? You see, the charge on K is plus 1, K plus. So 2 plus is the total charge on cations, and charge on one cation is 1 plus. So 2 plus by 1 plus is 2. So here X is equal to 2, or I can write K2 Zn OH whole 4. K2 Zn OH whole 4. Here you can find the value of X without writing X over here also. You can do in your mind so that it can be written. K2 Zn OH. You see, in writing the formula of a complex compound, we have to write the cations and anions. If it is an anionic complex, I can guess it from the name because 80 is over here, so complex part is written on the right hand side, and in the complex part I have to write the central metal atom or ion first, then the ligands written alphabetically, and the number of ligands can written by seeing the numerical prefix. Tetra is the numerical prefix over here, tetrahydroxidozincate. And then the charge on the complex anion and the cations, counter cations, can be found by balancing the charge on both sides. Then the number of cations as counterons can also be found, K2. Then example number 3, potassium trioxalato aluminate 3. Potassium trioxalato aluminate 3. You see, this is the complex part, this is the counter ion, this is an anionic complex. How? Because 80 is written over here. What is 3? The oxidation number of the central metal ion. What is the central ion? Metal atom? Central metal atom? This is aluminium. This is aluminium. And how many ligands are there? 3 ligands, but all these ligands are of same type, oxalato. Oxalato means it is from oxalate ion. Oxalate means CO minus, CO minus, or you can write OX2 minus. Tri means there are 3 oxalate ions, and this is also a homoleptic complex anion, and the counter ion is potassium. So let me write the central atom in the square bracket. First Al, then one type of ligands are there, and that is C2O4. This CO minus can be written as C2. How many O's are there? 4. And what is the charge on oxalate? 2 minus. C2O4. No need of writing the charge while writing the formula of a coordination compound. You see C2O4. Here it is written C2O4 2 minus, but here it is not written C2O4. And it is a polyatomic ligand, so it should be kept in parenthesis. Parenthesis means bracket. Parenthesis means bracket. Then how many oxalate ions are there as ligands? 3. So I should write 3 as subscript. AlC2O4 3. Then square bracket ends. This is an anionic complex. Why? 80 is there. So I should write minus sign, and I have to write a number over here. So I have to calculate by balancing the charge on the cation and anion. And here the cation is K. No need of writing X. If you will write X, then it is easy for you to calculate Kx. And you know the charge on K is +1. Now I have to find this charge first. You see, the charge on aluminum is +3. Charge on oxalato is 2 minus, 2 minus, 2 minus. So I can write -2 into 3 is equal to +3, -6 is equal to -3. And -3 is written as 3 minus. 3 minus. When it is 3 minus, the charge on the cation must be 3 plus. You see, this is written as Kx Al C2O4 whole 3 minus, over it is 3 plus. When it is 3 plus, I can find the value of x over here. How? You see, charge on counter cations, total charge. You see, total charge on counter cations is how much? 3 plus. However, charge on one cation K plus is equal to plus 1. I will write 1 plus. Then number of cations K plus, how much? 3 plus by 1 plus is equal to 3, or you can write plus 3 by plus 1 is equal to 3. So here x is found to be 3. This is x. This is what? This is x. So the formula of the complex compound will be K3Al_C2O4 whole 3. K3Al_C2O4 whole 3. And you see one thing, between tri and oxalato, you won't find any gap. You see, total name of the complex part is one word. Total name of the complex part is one word. Example 4. Dichlorido bis ethane 1,2-diamine. Dichlorido bis, then in square bracket ethane 1,2-diamine. You see, single M is there. Dichlorido bis ethane 1,2-diamine cobalt 3. Here it is written 3. Dichlorido, let me write again. Dichlorido bis ethane 1,2-diamine cobalt 3. You see, this is a bidental ligand, bigger ligand, so it is written in square bracket. And you see, the total name of the complex part is one word. There is no gap. No gap is there. Dichlorido bis ethane 1,2-diamine cobalt 3. Here we have to find the charge, whether it is a neutral complex or cationic complex or anionic complex. Let us find. In the name, we have to find the cation, we have to find the central metal atom first. Central metal atom first. Which atom? Central metal atom first. Then what is the central atom? That is cobalt, and it should be written in square bracket, cobalt. Then another part are ligands. You see, this is dichlorido, then this is bis ethane 1,2-diamine. Dichlorido means di means 2, chlorido means Cl minus. I should write CO. You see, there should be no gap between different letters, CO, Cl minus, but no need of writing the minus as well. CO, no need of writing the minus as above Cl, and there are 2 chloride ions, so I should write 2 COCl2, and you see ethane 1,2-diamine is written as En. So, and it should be written in parenthesis. I have written En, but you see bis is there. It is written it is written bis. It is written bis. What is that? Bis. Bis means two. Bis means two polydentate ligands, like di. Here di, here bis. The number is 2 in both cases, but bis in case of polydentate ligand. So as there are two ethane 1,2 diamine ligands, so I should write 2 over here. For bis I have to write 2. For di I have to write COCl2En2. Then I think all the ligands are written alphabetically. Chlorine, then E. And you know, in ethane 1,2 diamine, first letter of E, abbreviated name is written first, E, and this is C. So COCl2En2. Then square bracket ends. Then I have to write the charge above the coordination entity. And here it is written cobalt, no AT is there. So I think this is a positive charge cation, but let me find the charge. And you know CO is written as cobalt is followed by an upper Roman numeral, that is Roman letter 3, means the charge on it is +3. So let me find the charge above the square bracket. CO is +3. For chlorine it is -1 into 2. For En it is 0 into 2. En means CS2 CS2 NS2. This is ethane 1,2 diamine. It is a neutral molecule, neutral ligand, bidentate ligand, or you can say didentate. That is 0 into 2, and it is how much? +3 minus 2 plus 0 is +1. So charge on it is plus, and 1 should be written before, but we don't write 1 usually, so only 1 plus is enough. Only 1 plus is enough. So just write plus. You see, this is COCl2En2 plus. So this is a cation. This is a cation. So here there is no counterion, so I have to write the charge on the complex cation. COCl2 En whole 2. Let me write COCl2 En2, then plus. This is example number 4. Let me write the formula of example number 5. Tetracarbonyl nickel 0. You see, this is tetracarbonyl nickel 0. As there is no AT, so it is not anionic. As there are 4 ligands, so tetra is written 4. Carbonyl means CO. CO here is carbon monoxide. Nickel is the central metal atom. So I have to write the central metal atom first, then CO whole 4, then square bracket ends, and here the charge on the complex will be calculated as we have done above. Can we calculate as we have done above? Nickel, its oxidation number is, you know, nickel 0 is written, means this is 0, and you know carbon monoxide is a neutral molecule, it is also 0 into 4 is equal to 0. So total charge on the complex is 0, so NiCO whole 4. NiCO whole 4. This is tetracarbonyl nickel 0. Tetracarbonyl nickel 0. Tetracarbonyl nickel 0. This is example number 5. This is a neutral complex. This is a neutral complex because there is no charge on the complex part, or you can say coordination entity, and no need of writing the 0 over here. And this is a homoleptic complex because only one type of ligands are there, and the numerical prefix is tetra, means 4 CO ligands are there. Then example number 6. Diamine, you see 2 M's are written. Diamine, silver 1, dicyanide argentate, ARGENTATE. Diamine, silver 1, dicyanide argentate 1. This is very interesting. You see here 2 parts are there. On the left hand side means this is cation, on the right hand side means it is anion. Another confirmation for anionic complex, AT is there. Here no AT is there, so this is a cation, this is positive charge, this is negative charge coordination entity. Here both cation and anions are present. Means it has cationic complex part and anionic complex part. So we have to write the cation first. Di means 2, amine means NS3, silver means Ag. But in writing the coordination entity, we have to write the metal first, Ag, then ligands. How many amine molecules are there? 2, and it should be kept in parenthesis 2, AgNH3 2, then square bracket ends. I have to write the charge on it. How? You see here it is 1, means this is +1. Ammonia, 0 charged, or you can say neutral ligand. So 0 into 2 is equal to how much? +1. So I can write 1 plus. So no need of writing 1 plus, you just write plus over here. Okay. So this is AgNH3 plus. Let me write the anionic part. In square bracket you will write argentate means silver. I have to write the metal first, Ag, then di means 2, cyanide means Cn. No need of writing minus over here, no need of writing minus, as there are 2 cyanide or 2 cyanide ligands, so I should write 2 in the subscript after writing the parenthesis AgCN2. Then I have to find the charge above the cationic complex, and you see Ag has charge +1, cyanide has -1 into 2, +1 minus 2 is equal to -1. So the charge on it is 1 minus, but no need of writing 1 minus, you just write only minus. You see, I got the cation, I got the anion, and the charge on cation is +1 and charge on the anion is -1, so the charge is balanced. So I can write AgNH3 whole 2 AgCN whole 2. This is diamine silver 1, dicyanide argentate 1. Let us do another one. Tris, then in square bracket or in bracket ethane 1 2 diamine, single M is written over here, and bracket ends, cobalt, in parenthesis 3 is there, cobalt 3, sulfate. Sulfate is not a complex part, but this is SO4 2 minus, means anionic part. So this part is the coordination entity. Coordination entity. This part is the coordination entity. And tris means like tri. It is a numerical prefix for polydentate ligand like En, and for tris it is 3. If it is a simple one, simple ligand, then it could have written, then I could have written tri. But ethane 1 diamine is a polydentate ligand, so tris is written there. Tris means 3. Ethane 1 to diamine means En. Ethane 1 to diamine means the structure is CH2 CH2 NH2 NH2 like this, and it is written as En, abbreviated. And you see, in this complex part only one type of ligand is there, so it is a homoleptic complex, so no need of thinking about other ligands. And we have to write the central atom first. Here it is cobalt. Let me write cobalt first. Then square bracket starts En, then square bracket ends 3, then we have to find the charge on it before a plus sign, then SO4 X, SO4 has 2 minus charge. You see, we have to find the number over here before the positive charge. The upper Roman numeral for cobalt is plus 3. For En it is 0. 0 into 3 is equal to how much? Plus 3. Is equal to how much? Plus 3. So charge on cation is plus 3. Charge on anion is minus 2. But here 3 is not balanced by, plus 3 is not balanced by minus 2. So to balance this, we have to find balance. You see, here the charge on it is 3 plus, and here charge on it is 2 minus. So we have to find X and Y. You just do one thing, like you just write CO En3 3 SO4 2, only magnitude, then just write this 3 as the subscript of SO4, and this 2 as written as the subscript of the complex part, cation part. You see, then this is CO En3, I should write 2 over here, then SO4, no need of writing square bracket, write just moon bracket 3. You see, the formula is COEN3 whole to SO4 3. COEN whole 3 to SO4 3. If you want to write in detail, CO, this En is NH2 CH2 CH2 NH2 whole 3 square bracket ends SO4. Sorry. Let me write again. If you want to write En in detail, then I can write CO. If you want to write the name of the complex in detail or in full form, then CO. Sorry, if you want to write the formula of En over here, then we can write Cn S2N CS2. This En is written as S2N CS2 NS2 moon bracket ends 3 square bracket ends 2 SO4 in moon bracket then 3. Then do another example. Triamine. You see it is double M. Triamine. Then no gap is that. Tri aqua chromium 3 chloride. Chromium Roman letter 3 upper Roman 3 then chloride. So this is the cation, this is the anion, this is Cl minus, but we have to find X over here. Triamine aqua chromium 3 here the central atom is chromium after the starting of square bracket chromium, then triamine means we have to write 3 ammonia molecules, then aqua triamine triaqua chromium 3 chloride, but we have to find the number of chlorine atoms as counterions. Let me find the charge over here. Here the upper Roman numeral of chromium is 3 means its oxidation number is +3. For ammonia it is 0 into 3. For water it is also 0 and 3 because the 3 water molecules is equal to how much? +3. So it is 3 plus. We can do in another way. Cr NH3 whole 3 water, then this is 3, and for this is it is -1, or I can write only. So we can do one thing, this 3 can be written over here and this 1 can be written over here. Cr NH3 3 water, no need of writing 1, then Cl3, you see CrNH3 whole 2 CrNH3 whole 3 water, I have written only water, CrNH3 whole 3 water 3 Cl3. You see the formulae of the complex compound triamine triaqua chromium 3 chloride, CrNH3 whole 3 water whole 3 Cl3. So here I have given another trick. You see again, this is example number 6. Triamine triaqua chromium 3 chloride. Triamine means 3 ammonia molecules. Triaqua means 3 water molecules. Central metal atom is chromium. Chloride is the counter ion. 3 is the upper Roman numeral as the oxidation number. But we have to list the central metal atom first, chromium, then ligands A same, AM, AQ, so AM comes first, NS3, numerical prefix is 3, so I should write 3. Triaqua means, tri means 3, then square bracket ends, then I have to find the charge over it because it is a cationic complex, so a number is written before plus, then Cl minus. You see, this is plus 3, this is 0 into 3, this is 0 into 3 is equal to plus 3. So Cr NS3 whole 3, water whole 3, this is 3 plus, you know plus 3 is written as 3 plus, then Cl minus. Then you do one thing, remove this plus and minus, only write the number Cr NS3 whole 3, water whole 3, 3, 1. Then you just exchange Cr NS3 whole 3, water whole 3, 1, Cl3. No need of writing 1. So this is Cr NS3 whole 3, water 3, square bracket ends, Cl3. Thank you. If time and tide permit, then I will go for part 2. In part 2, I will start how to write the nomenclature of coordination compounds or coordination entities. Thank you.